Assalamu alaikum students. This video is related to the normal approximation to binomial distribution, right? That is another important topic where we apply the normal distribution in the case when it's actually a discrete data, discrete case, discrete variable case. But since it's a bit complicated or tedious to solve it by using the binomial distribution, then by using certain methods we apply the normal approximation, because that actually reduces our work and a long task. Now, first of all, as I said, the case should be of discrete. So over here it is given in question number 1 that the random variable x is distributed by the binomial distribution where the parameters of binomials are given to us. So I already told you that if binomial parameters are given, that means the n and p are given. So in this question what is given to us, that n is 200 and p is zero point 0.7. Now from this I can easily calculate that q should be equal to 0.3, right? Because we know that the sum should of these two should be equal to 1. Now since it's written in the question, use normal approximation. So since it's written, so fine, we can use it. Otherwise the first step what we take is always the check, right? We check, can I use this approximation or not? And what is the method to check it? Is np should be greater than 5 and nq should be greater than 5. Now if I do 200 multiplied by 0.7, the answer is 140, and obviously it's greater than 5. Fine, done. And for nq it's 200 multiplied by 0.3 and this answer is 60, again is greater than 5. So yes, we have the permission to go for the approximation. We can apply the normal approximation to solve the question. The second step we do is we have to use for the normal distribution z is equals to x minus mu upon sigma. So there we apply the second step because I need to know the value of mu and sigma. Now mu is basically the mean, which is in binomial distribution can be found out by using np. Similarly, sigma is the standard deviation, which can be found out by taking out npq and then under rooting it. All right, so do I have np over here? Yes, I do have, which is 200.7. so the mu value is 200 multiplied by 0.7, already done over here. So this answer is 140. And for the sigma we will do 200 into 0.7 into 0.3, which is going to be equal to 42. And when I take the under root of this value, because it's sigma means it's standard deviation, so that is 6.4807. Now I have these two answers, right, which we always find in the second step. And what is the reason for that? So in this z transformation I can write z is equals to x minus mu. Mu is 140 upon sigma is 6.4807, right? After this second step we move to the third step where we apply the correction factor, right? Correction factor is used because actually this is the binomial is a discrete case and normal is a continuous. So when we are going from discrete to continuous case, we apply the correction factor, and for that we have to, in this x value whatever is given the question, either we have to add or subtract 0.5. That's all about the approximation. So you just need to carry on with the 3 steps. What are those 3 steps? Firstly, you have to do this check. Second, find mu and sigma. And third is, whatever question is given, do it by applying the continuity correction in it. Now let's do part A. Part A is probability of x is greater than equal to 130. Do remember it's a discrete case. So when I am going to convert it to normal, I need to first of all, keeping x value as it is, convert it into the continuous. So for continuous, what is the easy way to remember? or just check it then and there. 130, let's say 130 is over here. So if I have to take the value of 130 is included, 130 is included, and I have to take all the values more than 130, so including 130, all right, and greater than 130. So if I take add zero point 0.5 in it and I start with 130.5, then obviously I'm excluding 130, which I do not, which I have to include it. So I must start from 129.5 onwards greater. So in that case 130 will be included, right? So this is same as after continuity correction is x is greater than equal to 129.5. So there you cannot ratify कि where you have to add or subtract, just find then and there. It all depends on the equal sign or not equal. If equal is there with the greater sign, we subtract. And there are four cases possible. One is with the greater, one with greater equal, less equal. So you just need to see where you have to add zero point 0.5, where you have to subtract zero point 0.5. Like in this case, what I did to include this thing, I subtract zero point 0.5, right? Similarly, if it's only greater given, I will just add zero point 0.5. For this value, if I have to do less than, let's say less than 130, then I must start with 129.5. So again subtracting thing, and over here I have to add it. So the best way is just make a number line there and then get the answer. Once you have this value, then nothing difficult, just plug in this x value over there. Probability of means I'm converting this whole x thing into the z thing. So it's z is greater than equal to 129.5. Okay, I do not have to write plus minus because I have already done minus. Then minus 140 upon 6.4807, that gives me z greater than equal to, um, just put in the calculator, and this answer is 1.62 with the negative sign. Okay, so rest of the working after that is same old one. And what is that? You know that you need to find out the area. Means if I draw it like this, so this is a z value given, and for that z value I want the probability area. So minus 0 is over here, so minus 1.620 is definitely on the left side of 0. What area I need? Greater than. I want this area, right? So for the greater than area, what I will do, I will subtract first of all, this value I will check in the z table, and from here I get this value as over here, the, the value I'm getting, like I showed to you. Okay, minus 1.62, so minus 1.6012, it's 0.5 0.05262. Okay, so 0.05262. So basically this area is 0.05262, right? Why this area? Because we know that table always gives us the area from minus infinity to that particular point. So this area, do I need the less than area or greater than? I need the greater area. So for that what I will do, I will just subtract 1 from it, and that is my final answer, which is 0.94738. Alright, similarly I can do the rest of the part in the similar way. Let me move it. Anyways, okay, so let's do the other part. Other part is about probability of x is more than equal to 136 and less than 148. So more than 136. Now you have understood the procedure. B part, I'm doing it here. Probability of x is more than greater than equal to 136 but less than 148. Again, I have already applied the correction the checking criteria. I have found the mu and variance. Now what I will do, I will apply the continuity correction. This is less than equal means on a number line, if this is 136, I have to take all the values but including 136. So I must start from 136.5, right? And for this value I want less than 148, so I'm not interested in including 148, so I can start with 147.5. all right, the rest of the working will be same, so doing it quickly. 136.5 minus mu was 140 upon standard deviation was 6.4 807 less than equal to z less than 147.5 minus 140 upon 6.4807, and then I need to find out its probability. That turns to minus 0.54 z and 1.1573. so basically, again, as I said earlier, never do normal distribution question without making this a sketch. So this is 0, minus value means on the left side minus 0.54, and this is 1.1573. I need to find out this area in between. So what is the way to find out? I will find because when I look this value in the table, I will get this area which was found as 0.2946 from here till here, and then when I will look this value, I will get again from minus infinity till here, which was found as 0.87698. so how can I find the intermediate area? This one, simply subtract these two values. Let's call it area A. Okay, I think something wrong with this. Area A, and this is area B. So my required area will be B minus A, right? So when I subtract it, I will get 0.58238. Alright, so this is the answer for the B part. Now C part is less than 148. Now it is very clear what steps you have to do, but if I look at the value of a value applied after continuity correction, that should be 141.5, right? Rest of the working same. Now this equals to 152. If equal sign comes, then what we do? Nothing difficult. If equal sign comes, then you simply do x equals to 152. Then that means, because in continuous data we don't have a value or a probability at the single value, so basically 152 will be taken as 151.5 in between 151.5 and 152.5. Since I have converted into the continuous data, doesn't matter you write this or you write this, because now I have already converted it, and then rest of the working will be same as we have done earlier. After that, convert this into the Z form, and after converting to the Z form, you can get the required area answer. All right, now if I write these values, I will have this value as 1.77, and this answer is 1.9288. so looking it on the table, it's again both values are positive, so both will be on the right side. 1.77, 1.9288. I need to find out this area. What I will do, just check this value in the table, get the area for this value, which will be from here till here, and for 1.928 the area will be from here till this end. So when I subtract these two, I will get the required area. Okay, So after listening till here, pause the video and then do the working again and check the answers from what I have done. Okay, I have taken one more question just for the practice purpose, right? uh, because this question is asked in the word form. Okay, it's changing the color to differentiate it. Okay, so at a particular hospital record show that the on average it's 80% of people appointment at the outpatient clinic. Find the probability that a day when 200 appointments. So now see, it's a n is equals to 200 given to us, right? 200 appointments and probability given to us also. N is equals to 200 and probability is equals to 80% means 0.8. Now what he's asking, now look at one first question, more than 170 patients. So the A part is more than 170 patients, more than 170 patients. So this is a case of discrete data. Now if I start applying the discrete value, what I will do, I know for discrete data, where's the pen? I can't find. Okay, for discrete data, we apply the binomial distribution NCX, PX, QN minus X. See, so if I start applying this over here, what will happen? It will be like for X is equals to 171, for X is equals to 172, for X is equals to 173. How long I have to go? For X is equals to 200. For so many values, for around 30 values, I have to apply this formula. So that's why it's not a smart way. It's not wrong, but it's not a smart way. So in such case, we apply the normal approximation if after check it satisfy. Like over here, the again check will be n into p, which is basically 200 into 0.8, which gives me answer 160. Absolutely right. I need the value more than 5, and nq is 200 into zero point 0.2, which is 40. So both checks says okay, yes, I can go ahead and apply the approximation. So since I, instead of doing all these long working of finding 171, 172, 173, now see what I will do. I need probability of x greater than 171. So that will be not, it's 170 actually. So after continuity correction, that turns to 170.5, right? So it's x minus mu is np. What is np value here is 160, I just calculated above, upon npq. Npq is like simply 200 into zero point 0.8 into zero point 0.2 npq and under root. So when I solve it, I will get the z value, and for z value, that z value I will find the z value is, sorry, z is equals to 1.679. So I need the greater one. So for greater one, I will have 1.67. Now this study is old one. That table will give me this probability, which is 0.95352. So from this value, if I subtract 1 minus 0.95352, I will get the 0.046 right answer, which is for the greater one, right? And same goes for this p part. This you can do easily. Only thing required is at least means now it's greater than equal to 155. So obviously when I convert into the continuity with the continuity correction, it will be x greater than equal to 154.5. The rest of the working will be same. I hope the approximation method is clear to you.